Let's look at the solution of prime puzzles. Oh, sorry, number system bytes. X is a 5-digit number, such that the 1000th digit of X is a prime number, and the product of all the digits of X has exactly 3 factors. How many values of X are possible? So if it's a 5-digit number with the 1000th digit being prime, additional info we have is the number X as a product of digits of X has exactly 3 factors. A number which has exactly 3 factors is equal to a prime square. Always will be a prime square. So if this is prime, I can have 4 different cases. Either it will be PP111 or 1PP11 or 1P1P1 or 1P11P. These are the only possible cases, 4 cases. And for the single digit prime number, there are 4 more cases. Sorry, not 4, 5 and 7. So I get the prime number could be any of these 4. And for every case out of whichever prime number you select, we get 4 more sub cases. So altogether, there will be 16 cases. Next question. I have 4 children. The ages in years of each child is a distinct positive integer between 2 and 16, both inclusive. 1 year ago, the square of the age of the oldest child was equal to the sum of squares of the ages of the other 3. 1 year hence, the sum of the squares of the ages of the oldest and the youngest will be equal to the sum of squares of ages of the other 2 children. If the difference in ages between the eldest and the second eldest is 2, find the sum of the present ages in years of all the 4 children. This question requires us to be very, very patient because this is a XAT type question. You will have a lot of time to attempt it. So let's see. First thing, we've been told the ages of children are distinct positive integers between 2 and 16. So the possibilities of ages are 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And squares of these numbers is 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Okay. We are told 1 year ago, the square of the age of the oldest child was equal to the sum of squares of the ages of the other 3. Okay. So now, 1 year ago, when we are looking at 1 year ago, the ages that would be in consideration, and changing the color a little bit, would be these. 1 year ago, their ages would lie in the range 2 to 14, all inclusive, because if it is currently 3, one kid has currently the age of 3, 1 year back his age would have been 2. Additionally, we are told the difference in ages in years between the eldest and the second eldest is 2. So I'm checking out all of these cases and seeing where the square of the two numbers, whatever is the difference, can I create that summation with any sum of any 2 squares? So I see 196 and 144. The first case I check is 144 and 196. The difference is 52. Can I make 52 with any of the square numbers that are given earlier? Not really. So this is not possible. Next is 121 and 169. Let's look at difference of their ages. I have 48. Can I make 48 with 2 numbers in this list here? Not really. So this is not possible. Then I have 100 and 144. Can I make 44 with 2 numbers in this list? Not really. Not possible. Then I have 81 and 121. Can I make a difference of 40 with 2 numbers in the list? Yes, I can. With 36 and 4. In which case, 1 year ago, the ages of the kids would be 9 and 11 and 6 and 3. So their current ages would be 7 and 12 and sorry, 10 and 7 here and 3 here. Sorry, not 3, 4 here. This is 2. This will be 3. Okay. Their current ages would be 10, 12, 7, and 3. We found one acceptable case. This does not mean we found all acceptable cases. We found just one acceptable case. We will continue finding more cases. 81, 121 is done. Next case to check is 64 and 100. Can I get 36 as a difference? Not really. Not summation of two numbers will lead me to 36. So this is impossible. This 40 was possible. 36 is not possible. Next is 49 and 81. The difference being 32. Can I make 32? See, whenever I'm checking, I'm only checking the numbers that are under it. Can I make 32 with two numbers under it? Not possible. Not happening. Next case to check would be 36 and 64. The difference is 28. The difference is 28. Can I make 28 with these numbers? Not really, not possible. Let me check 25 and 49. I need 24. No. I need 24. No, not possible. I can't get this difference either. Let me check 16 and 36. A difference of 20. I see now when I'm checking 16 and 36, these are the only two younger ages left. So 4 and 9, not possible. Can't make a case. Don't fall into the trap of thinking, no, 16 and 4 would work, because then two kids would have the same age previously. Not happening. And the final case to check is 9. In fact, I can't check anymore because the second oldest kid should ideally be at least 5 years old. If the acceptable ages of kids, current ages of kids is 3 and 4, the acceptable age of the second oldest kid last year can only be up till 4. I don't need to check any more cases, which means this is the only acceptable case. If this is the only acceptable case, let me also check if the second condition mentioned in the question is being satisfied. 1 year hence, the sum of squares of the ages of the oldest and the youngest. Oldest would be 12, so 1 year hence, this would give me 169. And 1 year hence, the age of the youngest would be 4, so square of that is 16, is equal to the sum of the ages of the other two. Sum of ages of the other two, 10 would have become 11, so that becomes 121. 7 would have become 8, so that is 64. So 169 plus 16 is 185. And 121 plus 64 is 185. So yes, the case that we have identified is accurate. Finally, we are asked sum of present ages in years of all the 4 children. The sum would be 10, 12, 7, 3. Everything adds up to 32. So that will be the answer. Next, Aparna has 10 weights of measures, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 grams. She lifts 2 weights at a time. What is the difference between the sum of the weights in the 10 heaviest pairs and the sum of weights in the 10 lightest pairs that she can lift? Okay. Basically, we have to identify the heaviest pairs and the lightest pairs. Given that the weights lie in the range 1 to 10, the heaviest pairs I'm listing out first. 19, which can be created from 10 and 9. 18, which can be created from 10 and 8. 17, which can be created from 10 and 7 and also 9 and 8. 16, which can be created from 10 and 6 and also 9 and 7. I've got the 6 heaviest pairs already. 15, which can be created from 10 and 5, 9 and 6, and also 8 and 7. And 14, which can be created from 10 and 4, and 9 and 5, and also 8 and 6. But if you include all the cases for 14, you've got 1, 2, 4, 6, 9. You only need one pair out of this. So whichever pair you take, that doesn't really matter. One pair, done. These are the heaviest pairs. Now let's look at the lightest pairs. The smallest weight that you can get is 3, which will be created with 1 and 2. Then you'll get 4, which will be created with 1 and 3. Then you look at 5, which we can be created with 1 and 4 and 2 and 3. Then you have 6, which can be created with 1 and 5 and 2 and 4. Then you have 7, which can be created with 1 and 6, 2 and 5, and 3 and 4. And finally, the weight of 8, I just need one pair of that because 9 pairs are already listed. One pair of that I'll do with 1 and 7. I need the difference between the counts here and the counts here. Here the count is 1, here the count is 1. As in 18 summation you get once, 17 you get 2 times, 16 you get 2 times, 15 you get 3 times, 14 you get 1 time. Similarly, the count here is 1, 1, 2, 2, 3 and 1. So basically 19 minus 3, 16, 18 minus 4, 14, 17 minus 5 is 12, but you get 2 such cases. So 24. 16 minus 6 is 10, but you get 2 such cases. So 20. 16 minus 6, you get 20. Okay. And 15 minus 7 is 8, and you get 3 such cases. So 24. And finally 14 minus 8, so 6. Let's add these up. We get 50 here. We get 54 here. So 54 and 50. All of this will add up to 108, which should be the answer to this question. Just confirming. 108 or 104? No, it will be 104, not 108, 104. The answer to the question should be 104. Okay, maths error. Next question. The sets P are defined as n comma n plus 1, n plus 2, 9 consecutive natural numbers, 9 consecutive natural numbers, where n is equal to 1, 2, 3, blah, 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 up till 520. How many of these sets contain a multiple of 70? Given that these are 9 consecutive natural numbers, any number that starts off with 17k is fine, or starts off from 17k minus 8 is fine. Let me use a different colored pen. Blue is getting hidden. If n was 17n plus k, or it was 17k minus 17k or 17k minus 8, each of these values would be acceptable. Or in every set of 17 consecutive natural numbers, the numbers that are useful for me are 17k minus 8 is as good as 17n plus 9. First, n being equal to 17k plus 9, or 17k plus 10, or 17k plus 11, plus 12, plus 13, plus 14, plus 15, plus 16, and 0. 17k, 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 and 17k. So the good thing is, as long as I have 17 consecutive natural numbers, 9 out of them are useful. So under 520, the largest multiple of 17 that I can see is 510. 510 into 9 by 17. Cancel, cancel, I get 30. 270 numbers are definitely counted. 270 numbers are definitely counted. What are left are 511, 512, 513, 14, 515, 516, 517, 518, 519, and 520. Among these, not useful, 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 not useful. But this is useful because if the first number was 517, if the first number was 519, the last number would be 527. And now the set contains a multiple of 17. So this will be counted, this will be counted. So 2 additional numbers in addition to 270. Final answer will be 272. Last question. In how many ways can 15 be written as product of two or more distinct integers without considering two integers with the same absolute value but opposite signs? So basically you cannot have a into minus a. So let's make cases. If I was writing 15 as product of two numbers, a and b, so the cases would be 1 into 15, 3 into 5, and also the negative versions of these, minus 1 into minus 15 and minus 3 into minus 5. There are no more cases for two integers. Let me check if I was writing 15 as product of three integers, a, b, c. One way I can see directly is 1 into 3 into 5. The other way I can see is out of these three, let me take any two as negative. So minus 1 into minus 3 into 5, minus 1 into 3 into minus 5, and finally 1 into minus 3 into minus 5. These would be acceptable. Can I make it for four integers? 15, A, B, C, D. No, it is not possible because this has only two distinct prime factors. You will not get any such case. So you get four cases from here, you get four cases from here, or altogether the answer to the question will be 8. Hopefully, the bunch of questions for today taught you something. These are more XAT type questions or ideas that are slightly advanced. Hopefully, they penetrated your head a little bit. That will be all. Okay, bye.